The first he got hurt, he cut his hand and he couldn't come. So only the three of us will be presenting the...
It's okay, yes.
So,
Please start.
yes.
So, hello everyone. First of all, I want to thank the University of St. Stefan for inviting us. We are truly honored to be here. Also, our good colleague and a dear friend, Csaba Farkas, for without him we wouldn't be here. He did all the good things for us to come here. Thank you. So, this project, what it's about? Well, Serbia has been going through some, we're from Serbia, we're from a small town in the western side of Serbia. As you all know, Serbia has been going through some rough years, rough economical years in the last couple of years. And we wanted to make a system that would help the economy of Serbia somehow. How do we do that? Well, Serbia is the fourth country in the world in production of raspberries. Basically, the town near us, near Užice, called Arilje, is the center, the heart of the raspberry production. Now, as you can see, we have four, and with that system we want to say very common, the greatest environmentalist of the 20th century defined four rules of ecology. Everything is connected to everything else, everything must go somewhere, nature knows best, and there is no such thing as free lunch. Now, why am I talking about ecology? Well, there's a system in information technology that is defined by these four rules. And the name of the system is Internet of Things. Now, what is Internet of Things? Basically, Internet of Things means everything is connected to everything. Imagine a forest, and you cut down one tree. That tree would send information to all other trees. Now, a team from Oxford started a project where they bought a whole forest, and they wired through every tree and gather data from the sensors, the heat signatures, everything, and they monitored the reaction from the trees. Now, how did they do that? Well, with one simple system, which is called VSM. That is the backbone of our system.
Thank you. Now this is the technical part, mine. The idea is to make a perfect crop to determine the parameters like soil moisture, air temperature and other stuff that are in an optimal range for us to produce, for example, raspberries. And the way to do that is to introduce something called the sensor field. Sensor field is the main part of a wireless sensor network. And the idea is to make connection between nature and computer and to have insight in the environment and what is going on in the environment. So these red dots, these are actually sensor nodes. They are collecting the data, but also they are transferring the data further to the gateway and to the base station. The whole idea is to have sensing, processing, and communication. There are many different access technologies like Bluetooth and 802.11 wireless LAN, but we propose using ZigBee, that's 802.15.4, because this is very important. Shared channel resources, they're very critical, and in our opinion, this protocol, ZigBee, is best at this. Also, certain types of wireless lines exist, as you all know, but a wireless PAN, wireless personal area network, is the one that ZigBee belongs to. Of course, there are many problems regarding this type of access technology. One of them is environment. Environment is quite severe. It's outdoor environment, and there are a lot of noise, interference, and other stuff. also real-time capability, because we would like, in theory, it would be perfect to have no latency, no rate at all. And of course, you need to be energy efficient. The whole process is like this. We are placing the sensors. The sensors are waking up and they broadcast in order to sense each other. And they are then forming the topology. First they connect to each other and then they form the topology. Now, there are two ways to transfer the data. First of all, I would like to emphasize that each node collects the data and also acts as a router. It sends the data further to the gateway. There are two modes, there are two ways to achieve that transfer. One is a single hop, where this node sends the data directly to the gateway. It isn't very energy efficient. The other mode that we propose is a multi-hop mode, where every node sends the data to his neighbor, and his neighbor sends to his neighbor, etc., until the gateway is reached. Now, what routing path should the data take? Well, there are several that you can see, but that comes along with this topology thing. You can see there are many types of topology. Star topology, it's obvious. You can see tree topology, chain topology, that's the first. But the computer needs to determine which one is the best. Of course, the whole system is very, very well, because it is self-organized, self-adaptation, etc. In other words, it's autonomous. There is no man, there's no people in it. It collects the data, receives the data, processes the data, and also builds a decision upon the data. Whether to, for example, to irrigate the crop or not. We suggest, instead of star or other topologies, using mesh topology or mesh network. Because mesh network is very flexible and it is very reliable. Every node sends a joining request. First, I'm sorry to forget to mention. First, it 1, 2, 3. First, it measures the signal strength of each node. Then, based on that measure, it sends the data, the joining request, to the node. The node sends the other node to his neighbor, and until which it reaches the gateway. Then, based on that facts, the gateway gives the proper network resources for every node. This is a logical scheme. This is our nodes and what they consist of. They are connected via that wireless SZENT network to the base station, where all the data are collected. And of course, we can access that data via router as part of the local area network, or through the internet using the remote access. For example, HTTP server. And that's all. Yeah.
So, I will talk about the hardware parts of our system. The power unit is responsible for reliable power. And then we got the sensors, which is in charge of transferring signals such as light, soil moisture, and air temperature into electrical signals. We got a microcontroller which receives and processes the data from our sensors and transceiver to sense the data further. Well, we choose Arduino as a microcontroller because it is open hardware project and it is made to be as simple as possible. We can attach sensor to Arduino, and Arduino can run on Macintosh OS 6, Linux, and Windows operating systems. This is the hardware base station. The core of our base station is Raspberry Pi computer, and the Raspberry Pi is one very small computer, single board. It is developed by Raspberry Pi Foundation. All models feature a Broadcom system on a chip with RAM-compatible CPU. Raspberry Pi promotes Python as a main programming language, but supports C, C++, Perl, Ruby, and others. For creating a base station, first we need to have installed operating system on our Raspberry Pi. We suggest Linux distro called Raspbian with MI12 implemented database solution, and optionally we can include Apache HTTP server for remote access.
So as you saw, what we want to achieve is or to make is a cheap, efficient, elegant, and intelligent system that would not need a human factor in it. So basically, everything that is done, it is doing it by itself. We wouldn't have any clause on it. It would just do it by itself. What we want to do is still a product in work. We want to evolve it and to include, for the further research, an allegation system that would react upon the information it receives. And that would be all, I think. Thank you for your attention. You may ask the questions.
Very nice common presentation. It was very interesting for me. You mentioned there are three main properties collections. This is soil moisture, okay, and light information and air condition. And what's your opinion? These three properties is independent or not? Is depend on each other or not?
Yes, they are attached to each other. For example, if you have a raspberry crop,
Yeah.
and if the soil moisture sensor detects that there is humidity moisture is below the optimal range, the first reaction would be just to pour the water, right? But you can't do that because if it's too hot, if it is above
but you know there are many cross effects. And you handle this problem, these cross effects or not?
Yes, it is.
Okay.
Because that's all done at the base station. Base station needs to compare that information, like information from soil moisture sensor, and to compare it to the, let's say, air temperature sensor. Because if the temperature of the air is too high, we can't irrigate the system. It will be destroy the plant. So the computer, the system, by itself, by his algorithm, his program, must take in concern just in this case we discussed only two sensors, to be precise 3. It would be best to have 100 more sensors to achieve more precise, to reduce the possibility for error.
Okay, and how do you communicate with the implant, with I think, precise irrigation system?
Yes.
You use isoboost or other
There are many
facilities used.
Yes, I understand. There are many solutions. That's irrigation part is our further next project.
Aha.
But we can, for example, take. Can I use the board? Is it okay?
Yes, it's okay. It's very good.
We can use a tank, right? Water.
Yeah.
We can get the autonomous pipe, right? And that would lead to no problem. And here we collect the data, right?
Okay. Yeah.
Here we collect the data. The data are sent through the gateway to the base station. And this base station is also connected wirelessly with this. Again, this pump is controlled using Raspberry Pi, for example. And it just needs to send a signal to the base station, and to put the signal, send the signal to this pipe to put the water, to open the water or not. That's one solution. Of course, you need to take care of what will happen if you try to put this to work, but the level of the water is here? Then this pipe would suck in the air, and the air would be in these pipes. It would be wet. So we need another sensor that will measure the capacity of the tank. And when it dropped it here, he said, okay, don't pour the water.
Okay. Other questions? You have any questions or not? Please.
So you believe that these sensors or these units on the field for days, for weeks, maybe?
Yes.
How could you organize that it not the safety of these sensors or that these sensors not to be stolen?
Basically, what we thought about is the weather conditions. For an example, if there's rain or lightning, I don't know, the connectivity can break. So what we thought is, this is still the further research of what we need to do. We could make a box, basically, that would just be connected to the ground, that would not interfere with the weather, it could not move, basically. It would be as a protection box. That's what we thought, but it still needs to evolve. So from stealing, from weather, from other stuff that can break the connection. If the connection is broke, then we might have some problems.
And also, we can just put the GPS sensor and also another sensor that will monitor that sensor node. Could be just like as above. So if anyone reaches within the range, I don't know, 2 meters, it will alert us. And maybe we can, this is now top of my head directly, we can set up the cameras that will take a photo if anyone reaches within that range. Some kind of prevention system.
It takes cost.
Yes, it is cost.
The main point of this project is the cheap stuff that will help. For an example, Serbian people, to just don't have to do the work, so the computer can do it. But even though if we want to improve, we have to have some larger funds. But for the first layer of the project, I think this could be pretty good and cheap.
What he's trying to say that the sensors are completely replaceable because they are cheap.
Just a short question, if I am allowed to ask. So, as far as I could realize that you are involved in a research work, which is a quite up-to-date, let's say, high-tech project. My question regards mainly to the management aspect of this project, asking that which part of this work can be dedicated to you as your own work. I mean, the information technology system development, data collection, or big data handling, or system control, automatization. So, which is mainly your part of work, or you are involved both of them?
Information technology. Collecting and processing the data with emphasis, with emphasis on the network. How network is transferring the data. That's our main.
Okay.
I think that the professor has another question.
I'm not a professor.
I'm sorry.
I don't want to ask. I have just a small idea that could be useful
No,
for
please.
the future. Because this system will collect a lot of data day by day, and by days and by time, you will have a lot of data, big data. Maybe if you develop a further system to analyze this data, so in the future the machine will not only take signals and give decisions, it also will analyze historical data and make decisions, whatever, or if there's no signal, it will just know that at this time, at this moment, I should give some decision.
Yes, you're quite right. And our intention is all that to happen at the base station. And base station should collect all data to enable us a statistic approach to analyze other stuff.
Yes, I forget to mention that boys came from Serbia, and I realized there is 4 presenters, and you are 3 only.
Yes, Milan Josipovic was the first one in GÖDÖLLÖ. He got hurt and he couldn't come. So
It's okay.
it's okay. He's
Yes.
okay, yes.
Yeah, I understand. Yeah, and I ask you to introduce yourself. You are.
I'm Milan Josipovic.
I congratulate you.
Thank you.
And you will get that.
Thank you,
That's
Professor.
paper. And you?
Miladin Tomic.
Yes, and something I congratulate you also. And you? Stefan? Congratulate.
Thank you.
It's very nice. Thank you. Okay.
Thank you all.
We take this
Very nice. And I think next presentation also is very nice. The title is Review for Affiliate Education Practices at Palestinian Higher Education.